Right then, let's begin with topic one, introduction to panel data. Let's have a look at the three common types of data. So when you do an analysis, you need to have a data set. Normally, you either have cross-sectional data or time series data or a combination of cross-sectional data and time series data, which we call panel data. You can see clearly here that cross-sectional data, you have data for one particular year across a number of countries, firms, individual. But for time series data, you have data for one specific entity, countries, firms, individuals, or respondent, collected over a number of periods or times. You can see here data for Australia over the years of 1995, 96, 97, and so on and so forth. Finally, we have panel data, which combines both dimensions. We have many countries or firms or individuals and respondent, and we also have many time periods. So you can see clearly here a number of countries and a number of years. So when we have panel data, it can be a balanced panel data where we have a complete data set available, no missing observations whatsoever. So data available for all individual n and all periods t. Therefore, number of observation will be n multiplied by t. But unbalanced panel if a situation where you have missing observation. Some countries have only, for example, 3 years or 4 years. Some other countries have complete number of years, which is in this case 5. So it will become an unbalanced panel data. So the choice of econometric methods will depend on the type of data that we have. Just now we talked about the cross-sectional data set. So normally, ordinary least square regression will be used for cross-sectional data set. And time series data, we will use time series analysis like unit root test, co-integration test, vector error correction model to uncover the long run relationship and short run dynamics. Because this is time series data, we have data over a long period of time. And for panel data analysis, we have bigger sample size because we have observation from different cross-sectional units and different time periods. Therefore, panel data analysis often allows us to capture the heterogeneity or the unique characteristic across units in the data set. So the method or the estimation that we can do for panel data set like fixed effects, random effect, and pool OLS. If we have a dynamic model, so we can also use difference and system GMM. But this technique will not be covered in this course because this is only an introduction to panel data analysis. If we have, let's say, long panel data where the time periods t greater than the number of cross-sectional unit n, therefore, we need to use panel analysis technique that can capture the unit root, co-integration, and long-run relationship. In this course, we are going to cover short or micro panel data because this is an introduction course. So our panel data will often have n greater than t or number of entities like countries, firms, individuals greater than number of time periods. Normally our data will be prepared like this. In the first column, we will put the name of the cross-sectional units. Here, the countries, followed by year for each individual country. So let's say we begin the year with 1990 until 1999. For the first country, Albania, we have all the data set for the respective years from 1990 to 1999. If we have missing observation, it means that we have blank data for any particular year for any particular countries. So in this case, we have data for year 1999 for country Albania is missing. The GDP data is missing here. So this is how we prepare our panel data before we begin any panel data analysis. Let's continue with the discussion on the sources of variation in panel data. I believe you have downloaded this data set, panel underscore data.dta, onto your computer. And please load the data set into startup program. And we are going to run this command and see for ourselves the graph like this. So what we are going to look here is that for variable y in our data set, we can clearly see the fluctuations of y across time periods, because this is the year on the x-axis. You can see here 1990 until 2000. So for each and every country here, you can see variable y have fluctuations across time periods. And when you compare between different countries, for example, Australia and Russia, you can also clearly see there are fluctuations in Y for Australia and Russia and for other countries as well. During specific year, for example, 1995, you can see Russia experiencing a very significant decline in Y, but for Australia, you can see Y is going on uptrend. The same goes to the other countries. For example, Denmark, quite stagnant level of Y, but Scotland experiencing a decline in Y. So we can clearly see here Y are fluctuating not only across time periods for each country, but also across countries. So let's try to do this command in our startup program. Our startup program. So you can click the button here, click button open, and locate the panel data file just now I have put on my desktop. So click desktop, and this is panel underscore data.dta, the dataset file. Click this dataset and click open. So you can see these are the variables inside the data. You can also inspect the data by clicking this data editor button. So you can see here the data editor window showing the list of countries, year, and the variables y, x1, x2, and x3. So just now, we are going to tell Stata the data is panel by running xtset command. Xtset followed by country, then year. So xtset is a command to tell Stata that our data here is panel. The country is the cross-sectional units identifier variable, and year is the time period identifier variable. So click OK. So Stata now understand that this is a panel data set. And then we follow by the next command xtline y. So this is to tell Stata to produce a graph of y according to the countries. So xtline y, and click OK. So we get the graph that we discussed just now. So going back to our sources of variation in panel data, in panel data, remember I mentioned earlier about the unique characteristics belonging to the cross-sectional units. So when we collect data across different countries and different time periods, there will be a unique characteristic belonging to any particular country that we don't observe, but they are present in our data. So these variables that you cannot observe or measure, but they represent a unique characteristic. This unique characteristic must be captured before we can estimate the relationship in panel data. So this unique characteristic often called time invariant factors, variables that are constant across time, so they don't have the variation, and we don't observe them. The variable that we have in the data just now, y, x1, x2, x3, there are the observed variables. So we can clearly see the variation. But there must be unique characteristic belonging to the countries in the data, like Australia, Russia, for example. Of course, the culture, the status of the country, whether it is a landlocked country or not. This characteristic, this constant unique characteristic is definitely going to give an impact in the relationship between x1, x2, x3, and y. If we say y is GDP, x1 is the trade, so the impact of trade on GDP between Russia, Australia, or any other countries definitely is going to be different because of the people's culture or any other unique characteristic belonging to the country. So the same goes to analysis about income, for example. The person's ability, preferences, skill set, and knowledge perhaps might influence their performance, influence their access to education, and eventually influence their income level. And the same goes to the analysis of firm profitability, which might depend on the board of directors characteristic, the atmosphere in the firm, and so on. All these are unobserved factors that might impact the relationship. They are constant across time, so we call them time invariant factors. The other possible factor that might exist is individual invariant factors. It means that it may change over time, but they are constant across entities. So we have zero between variation, meaning that when we compare between the countries, no variation whatsoever. This is quite unique because when we think, for example, international agreement, this set of countries in our data throughout the period, let's say for the initial years, they don't have any specific agreement. So that unique factors, that unique characteristic does not exist yet. Midway through the sample data, they implement an international agreement regarding their trade. So then the unique characteristic appear, but there appear within the time period, not throughout all period, but only midway through the time period. But this international agreement applicable to all countries. So no different between these countries in the sample data. Or maybe we have data like firms within one country. So this is another example, unlike our panel data set just now. So this is, for example, many firms within one country. So if we include variables belonging to the country, like policies, federal regulations, or macroeconomic data like GDP, inflation, definitely this data set is going to be constant for all firms for any particular year because the data belong to the whole country, which is the same data that is applicable for all firms. Okay, now we come to the last discussion in topic one, the advantages and disadvantages of panel data. As for the advantages, we know that panel data has the ability to account for heterogeneity across individuals. We discussed earlier about the unique characteristic between cross-sectional units, and therefore this unique characteristic, or the other term that we often use to call it is unobserved heterogeneity. This unobserved heterogeneity factor across individual units must be captured in our analysis. If this characteristic or this factor is ignored in pooled data, it will lead to less robust estimation due to omitted variable bias. Panel data also offer a larger sample size because we can collect data from many cross-sectional units and many years. Therefore, we are going to have a larger sample size and multiplied by t is going to be bigger than the simple cross-sectional data or the time series data. Because of the larger sample size, we are going to get more information from the data because more variations available. The data will be less collinear between them, and from the more information that we have, it's going to lead to the more precise estimate. And finally, we are able to study the dynamics of the relationship because we collect data across multiple time period, so we can see the dynamics of adjustment over times. However, the disadvantages of the panel data is that because the data is always large in size, it may be having difficulties in maintenance, and also some missing observation might happen, which will impact our estimation. Because we are collecting for many countries or many firms, some countries might have missing observations, and therefore it might impact our analysis. The other disadvantages is measurement error or distortions because the issue of a clear measurement definition that may not be applicable to all countries. Therefore, when we gather data for all countries or firms, some countries might presume the data is not really reflecting the actual measurement that should be done. So these differences in measurement could lead to what we call distortions or measurement error. And then the selection bias, because a group of countries or a group of firms that we select is based on our preset decision, or based on our earlier scope of analysis, and therefore we might omit some group of countries or some group of firms, and therefore leading to an issue of selection bias, which is not really an issue of the heterogeneity factor that we mentioned earlier. So these are the advantages and disadvantages of panel data. So we come to the end of topic one. We are going to continue with topic two afterwards.